Okay, we'll start now. The last class we discussed about that interrupt controller. The interrupt controller we start with now, right? So here we already discussed that one interrupt, right? So we can have now interrupt 0 to 7. Interrupt we can allow. Then we are giving the priority. Then using the priority, you it will resolve the priority, and then it will send that interrupt service, right? So here we can have any number of interrupt. Okay, we are having now that any number of interrupt IR0 to IR7. So 8 interrupt we are having now. That interrupt means we are connecting with the external device. The external device can make a request. So that request is going to be resolved, and then it will service by some routine. Okay, that is we already discussed. Now we will see that one here. We are having that controller, interrupt controller, one IC. That IC we are going to see now, right? So 8259 is interrupt controller. The 8259 is interrupt controller. Now that interrupt controller is going to use along with that 8085 processor. So this is the 8086 processor. In that 8086 processor, we are having a data bus A0 to A7. So here that 8-bit data we are going to have now connect with that your 8259. The 8259 is interrupt controller. In that interrupt controller and data bus we are having 0 to 7, so 8-bit. This data bus is going to be used for the interrupt, right? So here we are having an interrupt I0 to I7. We are having now that allow that interrupt. Then for that interrupt, then it will make a interrupt type, and then the type is passed on to the data bus. Then along what type of interrupt it is, so that the interrupt is going to be processed, right? Now here we see that one we are having that any one of that interrupt is going to come now. Then it will give now interrupt request. So that is through the interrupt. So through that interrupt, then that interrupt is going to have now. So this is the interrupt, right? So in that interrupt part, it will make a request. Now this request is going to resolve. Then it will send that acknowledgement. So the interrupt is going to be serviced. That acknowledge. Then the interrupt is going to be serviced now. So this is the interrupt controller connection between that 8086, that interrupt controller 8259. That the external interrupt is going to be allowed. Now here we have to make a program, right? So what we are going to have now, right? So that is we already discussed that one. What are the devices are components are there in that interrupt controller, right? That components are there. Then the detailed discussion about that controller. So that is the data bus buffer. So that data bus buffer is used for sending the data, right? So what data we are sending now, that data is going to be placed in data bus buffer, right? Now here the read write logic is there. Then we are having that cascading that buffer, right? So here we are having 8 interrupt is allowed. Then we can have now around 7 another 8 interrupt controller we can connect with as a cascading. So CAS 0 1 2. So here 3 digits. So the 3 digit we are having 0002 and 7. So we can have the concatenate with another 8. So the total 64 interrupt can be allowed through the cascading. So that is we are having cascade buffer is there. Then we can have now that cascade buffer is. Now here we are having now that interrupt. So what interrupt is going to make request? Then the in that register it is registered. Then the priority resolver is resolving. The higher priority interrupt is allowed. Then the interrupt service register we are having what type of service is going to be done, right? Here we are having the interrupt mask register. So in that interrupt, which interrupt is going to be allowed, then this some interrupt may be not allowed. Then that can be masked here. So interrupt mask register are there. Then using that mask register, then here that we can allow a particular interrupt only through the mask register. That also we can see, right? Now here the data bus buffer, then read write control logic. The control logic we are having now. Now we go for that one, right? So that is we are having now. We already discussed, but once again then we'll do that one. Okay. Here we are having now the data bus buffer is, we are having now the data is here 8-bit data we can have it transfer between the processor and the device, right? So here we are having now the trade like that is we already discussed. The interrupt request register is the what it store all the interrupt level which are requesting for interrupt service, right? The interrupt service register it store the interrupt level currently being executed. Now interrupt mask register it store the interrupt level which have to be masked by storing the masking bit. We will see that. So this is we are having now the priority reservable cascade buffer, that is we already discussed. We will go for the directly the IC, right? Now here we are having now that the Intel 8259. So the 8259 is actually we are having now the interrupt controller. Then here this interrupt controller can be programmed. It is as like that 8255 we can program. Here we are having now in level trigger, edge trigger, interrupt. So that is we already discussed that one. So what is the level trigger and edge trigger is, here we are having now trigger is we are having now this pulse. Then here we are having the positive logic trigger. In that place if you are triggering, then that is called positive logic trigger. Here if suppose we are triggering here, this is negative logic trigger. So this is negative large. Then this in that place if you are having that allowed, then that is called level trigger. So this is level trigger, right? So this is level. This is we are having now edge level trigger. This is edge trigger, right? So the edge trigger we can have now. So that is called, here we are having level trigger and edge trigger is allowed, right? Level trigger and edge trigger we can allow now. So we can mask the individual bit of the interrupt. I told you that one IR0 to IR7. So we are having 8 interrupt is connected now. Then in that 8 interrupt, suppose we want to mask that first 4 interrupt, another 4 interrupt only allowed. Then we can mask it through the interrupt request register. You see that one. We can here we are having now. We can increase. I told you that one. This is one 8259 can handle 8 interrupt. Then we can cascade another 8259. Then through that one 8 into 8, 64 interrupt we can have now cascading further, right? Further 8259 programmable interrupt controller. PIC is programmable interrupt controller, PIC, right? So that 8259 is programmable interrupt controller. Here in that IC, so what are the pin diagram? So pin diagram here we will see that one. So this is we are having now the data bus buffer. So that is we are having T0 to T7 we can have now. Then we are having now that interrupt, the external interrupt around we are having 8 interrupt allowed for one IC. So that is IR0 to I7, right? So the if you are one interrupt is occur, now interrupt is going to send from here interrupt pin to the 8 to 86. So here we are having now 8086. We are having that, right? 8086, right? So that we are going to have now, right? So the cascade we can do through we can have that one through the cascading is CA0 1 2. So around another 8 to 59 chip, right? So the same chip we can have now, the many chips we can have now, then each one is connected with as cascading. Then we can have now this is 8, then another 8. So totally 64 interrupt can be allowed, right? 64 interrupt can be allowed now, right? It's that. Next, so here in that as like the 8255, the 8259 also we are having some control words, right? So here we are having two part we are having. So initially we can have now the initialization command word, right? ICW and OCW. So we are having two command words, right? So that is initialization command word and operating command word. So we are having two types, ICW and OCW. So in that case, in the 8255 we are having only one control word. In that 8259, this is the programmable interrupt controller, where we are having now two command words. Two type of command words we are having ICW, OCW. In the 2 mark they may ask question. So here we are having ICW, OCW. So that ICW we can have now many values are there. The first value, so ICW1, ICW2 are compulsory for initialization. So first and ICW0 and ICW1 are important command word. Right. So this is ICW0 and ICW1. These two are compulsory. These two are compulsory. So we record. Then after that ICW3 is given during the cascade count. Suppose we are having that we are having only 18259, then ICW3 is not required. If you are having around further cascading is there, then we have to use the ICW3 also. Then ICW4 is needed if when the ICW1 we have to specify that one whether we are having this control word is required or not, right? So that is mentioned in the ICW1, then we can use that ICW4. So that is we are going to see that now, right? Now in what order we are going to, so first control word it will go to the ICW1, second control word it will go to the ICW2, third one is ICW3, and fourth one is ICW4. The sequence order we are having now. ICW1 is given first, and then ICW2, and then ICW3. In that sequence we have to give now the control word. Okay, so here we will see the how do you initialize that one here. Right, then next one is operating command. After initialization, then we can do that operation. In that operation we are having operating command word, that we are going to see that one, that operating command word what we are going to see is. Okay, now first one, the ICW1. This ICW1 is actually we are having initialization command word 1. This ICW1 is having that A5 to A5, A6, A7. This is we are going to use for interrupt vector address. Interrupt vector address is used, right? So this is the interrupt vector address. Now here, so we can have now around 3 digits. So 3 digits means we are having 0 to 8, right? So that one we can have now. Next one, here this is always we have to give now the value 1. In the T4 you have to give always 1. Then next one as we are having the level trigger, right? So that is we are having edge trigger or level trigger. 0 means it is edge trigger. If you are giving this value as 0, this is going to have edge trigger, whether it is positive edge or negative edge we can see. So edge trigger means it will trigger and the increase to a decrease, right? So it will trigger here. That is called edge trigger, right? Edge trigger, right? Next one, if you are giving that value 1, this is under level trigger. Level trigger is in that place we are triggering. Triggering means we are changing, we are transition is going to happen now in the edge trigger or in the level trigger. So we are, what trigger we are going to use, then we have to give now the corresponding value. 0 for edge trigger and 1 for level trigger. Next one, here AD1, right? So here we are having now the call address interval is here we are having some delay. Then that is we can have now 4 interval we can use that 1, and 8 interval we can use it 0. 8 interval we use as 0. That is we see that, right? So that is 1 is 4 and 0 is 8. 1 is 4 and 0 is 8. Right. Next one. Here we are having now whether we are using a single 8259 or we are having cascading, so you have to mention that one, right? So 1 is single mode. If you are giving that 1 is single mode, if you are giving 0, then this is we are having now. Check. Then the last one is here, whether we are using the control word 4. I told you that one, whether it is needed or not, right? So ICW4 is needed, then in the ICW1 you have to mention this is 1. If ICW is not required, then we have to mention is 0. We can have now the corresponding one, right? Next one, the next control word is ICW2. In that ICW2, what we are going to have now, the interrupt vector address. So for which particular address we are going to have now that interrupt vector, the content, right? So that is interrupt, where is the interrupt vector? So where we are having the corresponding address, we are going to have now that A15 to A8, A8, right? So this is we are having that address one. This is going to have now that interrupt vector. In the interrupt vector, we are having now that correspond to routine address, right? Where we are having routine address. So first routine, second routine, third routine. Right? We are having the interrupt vector. Then we are having which interrupt. One interrupt means vector as itself. We are having one address, we are having the quantity. Interrupt routine is there. That routine is going to execute. So that is in the I2 we have to mention about the interrupt where that interrupt vector. So we are having that interrupt vector address, we have to mention that one, right? Then if you are having 8086, the 8085 if you are using now, the A15 to A8 is used by the interrupt vector. In that case of 8086 to 88, then we can use now as a T7 to T3 is used for vector address. This 3 is not used now, right? So that is we are going to have now as in 8086, right? So first one, if you are sending the data, then ICW1 data we have to mention. Using that one, then we can have now. So here you see this one, IR7 is the highest priority. The priority is 7. Then IR0 is priority 0. So if you are having that number is high, that priority, that interrupt is having higher priority. So higher priority should be placed in I7. The lower priority should be placed in IR0. Right. Then here we are having now IC4 command is not required. So that is here the T0, right? So that one is here ICW4 is not used means the T0, the first digit, right? Released LSP. LSP is 0, then the ICW4 is not used. If IC4 is used, then that's that LSP bit we have to make it as 1, right? Then we are having now that we can have a special mask mode is reset the status read. You see that one what this is, right? Then ICW2, right? So in that ICW2 I told you that one interrupt vector address. So that is we are having now the interrupt vector address we are having now. So that one when A0 is 0, right? So we are having recognize ICW as address when A0 register bit is 1, then it is having that interrupt vector address. Interrupt vector address we are having now in the second command word, right? Next one, that operating word, right? So operating word means where we are going to first one is mask. So mask is here if you are having oneness we are having now closed, 0 is open, right? So here oneness it is masked, 0 is unmasked. So here we are having now the oneness not allowed, right? 0 is allowing. So that interrupt if you are having connect with the IR0 to IR7, we are having that connected. Then IR0 to IR7 is connected now. Then here suppose that by IR5 is if you want to mask, then we have to make it as 1. If it is masked, then we have to make it as 1. If it is open, then we have to make it as 0. So what interrupt is allowed, then what interrupt is not allowed, then we have to use the mask. So one is mask set. So one is as like that closed, right? So the door is closed. Then we are having now this is the door is open. O is open, right? 0 is open, right? So that is we are having now 0 is open. That the mask is reset, right? So mask reset means then we are having now the mask is set means the mask that interrupt is not allowed. That is we are having now that operating. So our operation is whether we that particular interrupt is allowed or not. So we are having everything is allowed, all are 0. Everything is closed, then all are 1. Right? So that is we are having now that operating command. Okay, so these are all the 8 to 5, right? So the interrupt control is over. So we are having now that in that interrupt control we have to consider now. So what is the interrupt block diagram? Then in that block diagram we have to explain about that one, right? So you have to write the block diagram, right? So that is interrupt control. We are having now then it will go for the detailed diagram, and then we have to go for the pin diagrams, and then we connection 8086 and 8259, and then we have to mention about that components, and then we have to go for components, and then we have to go for priority and then pin diagram, right? So that is we are going to have now, then we give the details, right? So that is we will see, and then we have to mention about the control words. So these are all the important requirement of the DA2. So this is the important question. So describe about that interrupt controller or 8259 IC, like they may ask. So you have to explain in detail. Otherwise, they may tell that what is the control words in control. So we are control word, the initialization control word, other one operating control word. The initialization control word, we are having ICW1, ICW2, ICW3, ICW4, right? If you want to have the ICW4, in that should be mentioned in the ICW1. So that is we are having now as interrupt controller. Next one is we are having now DMA controller. Okay, so DMA, direct memory access. So what do you mean by the direct memory addresses? Actually, if you want to get the data from memory to external device, then the CPU is going to take the data and it will send the data to the external one, right? Now, in the DMA controller, what it will do now? It will do that one, the direct memory access. Direct memory access means from the memory directly we can go for the IO device, right? For example, if you are printing your data, we want to print your file in the printer. So printer is IO device. Your file is in the memory. So from the memory to IO device without intervening about that CPU, right? So now the DMA is a controller. It will request the CPU to relinquish address bus and data bus for direct memory access. The CPU will release that address bus and data bus for DMA, and then it will give the give acknowledgement. Then the DMA controller start to transfer the data from the memory to the external world. External world means it may be printer or it may be your pen drive or something, right? So like we can transfer the data from memory to directly. So that is called direct memory access. Actually, for accessing memory, we have to use CPU. In that case of DMA controller, it will take a request from the CPU. Then the CPU is release its address bus and data bus for use of the data transfer, direct transfer. Now the DMA controller will take the address bus and data bus and it will transfer the data. After completing the transfer of the data, now it will release its address bus and data bus to CPU. Right? Now you see this one. So we are having now bus grant, right? So what do you mean by that one is bus is released and granted to that's it. So here we are having CPU can communicate with the DMA register. So that DMA is asking the request. Now the CPU will grant that one. So we are having now, you see this one, read write or two-based input, right? So if we are PG means bus grant. Input is 0, the CPU can communicate with the DMA register. Then PG input is 1, so that is we are coming now. The CPU has relinquished the buses and the DMA can communicate directly with the memory, right? So we are having this is the bus grant. Bus is granted to DMA controller by the CPU. So after that, the CPU is waiting for releasing the bus, right? So if the DMA is take the control of the bus, at the time the bus grant is 1. The bus grant 1 means the bus is released to DMA, right? Bus grant 0 means the CPU is ready to communicate with the DMA register. The DMA register will ask the request, then it will release the address bus and data buses, right? So now you see this one. Here we are having now the DMA access, direct memory access, where we are having now we are black diagram for direct memory, right? So here we are having now what we are having the starting address. So here in the DMA controller is having from which starting address we are transferring a block of data. So if you are having a transferring a block of data, starting address and the number of words. So how many number of words we are sending the transfer, right? So if you are having 1000 byte file, right? Or we are having 10,000 byte file, then we are having the starting address of the file, and then we are having here word count is 10,000. Then it will take the data through the data register and it will transfer now, right? That every transfer is going to happen now by the control, right? So this control branch we are having now. This is using the control. So here we are having DMA request, right? So that is we are now DMA request is coming now. That having now that interrupt is going to happen now. Then we can have now read and write. Whether we want to have the read data or write data, we can have now. So we are having transfer the data from external device to internal. We can transfer the data. So this is the DMA diagram, right? Now in overall simple diagram, right? So now you see this one. Here we are having a CPU. Now if you want to transfer the data, now the DMA memory access controller will send the request, right? That is we are having now the interrupt, right? So here we are having now it will send the interrupt, then it will ask that one that we are having first grant, right? So we are having now grant, we are having now and bus can have now. We can have now this address bus data register. We can have now the selection of the data. Here you see this one. This is the RAM memory. From the RAM memory, direct IO device we can communicate. Right? Now this data bus is released and the data is transferred. Where we are coming from which address, and then we are having word count will be there. Through the word count, then it will transfer the data. Whether it want to transfer that from RAM to IO, that is right. Read is here RAM to IO. Write is from IO to RAM. We can transfer the data. So that is right. That one we can do now, right? So this is IO device. This IO device request. Now the request make then the interrupt is going to be handled, then the bus is granted now, then the bus is granted now, then it will do that operation as the DMA is acknowledged. Now the bus is ready for communication, then the IO device is transferred the data. After completing the data, so that block of data is transferring, then after completing that data, then bus release. So grant and release. So release will send now it will take control by the CPU. So this is we are having now the direct memory access DMA controller, right? So that is we are having now. So today we are going to see that one interrupt controller. The 8259 we are having that programmable interrupt controller. Next one is direct memory access. The DMA is directly we can transfer the data from memory to IO device or IO device to memory. Then for that we are having, it will make a request. The IO device you want to transfer the data, it will request the TMA controller. The TMA controller make an interrupt to CPU. Now the CPU is release the bus grant. Then bus grant means then it will allow that one. Then it will get send a TMA acknowledgement. Now the IO device is ready to transfer the data. After completing the data, then DMA controller will release the bus and it will send bus release. Then the CPU will take over the address bus and data bus. Right? So this is the way of communicating direct communication. Right? So direct memory access. Right? That's all today. If you are having any doubt, you can ask now. Chandran, can you understand now?
Yes, sir.
Anybody else we can ask question now? Sushant, okay. Anybody else?